Okay, so if I copy down my givens, so BK bisects angle ABC, and then I also have angle 2 is equal to angle 4. So those are my given pieces of information. So I'm going to label angle 2 is equal to angle 4. Okay, and then the fact that BK bisects angle ABC, if you have to work through a proof on your own, okay, without the sequence being given to you, okay, what you want to do is follow one of two steps. And it doesn't matter the order that you do these. You either interpret the given information and find any statements that are relevant to that, or you try to introduce the end state elements. Okay, so normally what I'll do is interpret the given information. So the fact that BK right here bisects angle ABC, this whole angle, tells me what has to be true, what angles are equal. Bisects mean angles 3 and 4 have to be equal. Okay, so if I say angle 3 is equal to angle 4, that's definition of that term. Because the term appears earlier in my proof, I can use the definition of that. And again, you can only use it if it's very specific and the word appears in your proof, or if an image, the diagram, demonstrates that definition. All right, so now I've interpreted my given statement. So the next step is to start introducing some end state elements. Okay, so as I look to introduce these, I need to have angle 1 and angle 5 introduced into my proof. Okay, so a couple different ways that you can approach this. Okay, angle 5, the only way I can introduce angle 5 into my proof is as this linear pair. Okay, so if I introduce that, I have angle 3 plus measure of angle 5 is equal to 180 by definition of linear pair. Okay, now, I've introduced my end state element 5. Okay, I also introduced an element that's already in my proof. The more you can introduce, or the more you can relate things that are already in your proof, again, the more likely it is that that's going to lead you to a valid conclusion. All right, so I've introduced angle 5. I now need to introduce angle 1. Well, in looking at this, angle 1 and 5, if 5 is related to 180 degrees in this equation here, if there's a way that I can introduce angle 1 into my proof within that same methodology, I want to do it if I can. So here when I'm looking, I have angle 1 plus angle 2 is equal to 180 degrees, right? I can keep that as the same statement, so I'm going to, since that's also definition of linear pair, I'm just going to include it in that same statement 3. Okay, so now I've introduced both end state elements. I now need to get them on different sides of my equation. So the way I can do that is if I set these two things, they're both equal to the same thing, therefore I can set them equal to each other. I'm going to put the angle 1 on the left, so angle 1 plus angle 2 is equal to angle 3 plus angle 5. And what justifies this statement? Two things equal to the same thing are equal to each other is transitive property or substitution. All right. So what I need to do is somehow figure out a way to be left with angle 1 equals angle 5. I need to remove angle 2 from one side and angle 3 from the other side. Okay, so when I look at those, is there any way I can relate angles 2 and 3? Angle 2 and 3 are equal because of what? So here's angle 3, here's angle 2. They're both in my proof earlier. Are they set equal to the same thing? Yes, they are. So by transitive property or substitution, 2 and 3 are equal, which then leads me to my final conclusion here. I can take this statement right here, subtract angle 2 from one side, and I could balance the equation by subtracting angle 3 from the other side. And if you remove equals from the equals, the remainders are equal, is justified as what? Subtraction property would be your final step.